This graph is called a frequency spectrum. Here we have frequency on the horizontal axis and amplitude on the vertical axis, and each line represents a sine wave. That is, the horizontal position of each line gives us the frequency of the sine wave, and the height of the line is the amplitude at that frequency. When we obtain the frequency spectrum of a musical tone produced by an instrument, we see various frequency components. The lowest is called the fundamental frequency. This frequency determines the musical note of the tone, which are the frequencies I explained in the episode on musical frequencies. The fundamental frequency and all frequencies that are multiples of the fundamental are called harmonics, and the fundamental is considered the first harmonic. The rest would be the upper harmonics or overtones. Typically, musical tones will only have harmonic components, that is, components with frequencies that are multiples of the fundamental. For example, if we play the note A3, which has a frequency of 220 Hz, then the tone will have components at 220, 440, 660, 880, etc. The square wave is a somewhat special case, since it skips the even multiples. Strangely, bells and some other tonal percussions produce inharmonic components, that is, frequencies that are not multiples of the fundamental. This is due to the shape of such instruments and the dispersion of bending waves, but that is a more advanced topic that I will not go over in this video. The sounds where we do not distinguish a specific musical note, such as those of non-tonal percussions, will not really have a fundamental and components at specific frequencies, but rather they will have a complex spectrum. Here we can see that each musical instrument has its characteristic spectrum even when they play the same note. The frequencies are the same, but their amplitudes are different. So, the amplitudes of the components is what gives each instrument its timbre, or more accurately, the ratios between the amplitudes. We can also see that the fundamental frequency is not necessarily the one with the greatest amplitude. Musicians often refer to timbre as the color of the tone. This is an analogy of how the colors that we perceive visually are also combinations of different frequencies, just that in the case of colors, they are electromagnetic frequencies. The waveform, the frequency spectrum, and the perception of timbre are all directly related.